this force is independent on the path. Now we are discussing about the non-conservative force. Here we can defining this non-conservative force. So a force is said to be a non-conservative if the work done by the force of that particle which is moving between the 2 points. If you apply the force, the particle will be moved from one place to another place or one point to another point, and this work done will be depends on that path. In our non-conservative system, non-conservative force, if you apply the force, the work done by that force, this work done by that force will be depends on the path. Here we can see the system or is simple, the work done will be depends on the path of that followed by that particle. So in our previous we just see that the work done will be under the application of the same force. The work done will does not follow the path, or simply we can say that which is independent on the path. In our conservative non-conservative system, this work done under the application of that force which moving, this particle will be moving from one position to another position, will be depends on that path. Again, similar to our conservative system, we can considering the round trip journey. So this non-conservative force, again we defining another definition. If the work done by that force moving a body over a closed loop, or we can say that round trip journey, round trip. Okay, in that round trip journey or the closed loop. So if the work done by the force the moving body over a closed loop during the any round trip journey is non-zero, so the total work done will be non-zero. There is a simple definitions. From this we get any closed journey, any closed loop, or in that round journey the total work done will be non-zero. In our conservative system we can see that the total work done in that round journey or round trip will be 0. So here there are many examples. In that example we can see that the frictional force, when we are walking, when any subject will be, if you push the any substance from any friction rough surface, in that rough surface we can see that the frictional force will be exerted. So this frictional force which is having the non-conservative force, this is the best example for our non-conservative system. We can explain with the one simple example. So here we are considering the one block. Here we are considering okay. So this block which is having at the position 1A, here this we are considering the one block which is on the rough horizontal surface. Here I am considering a rough horizontal surface. If it is a rough, then the more frictional force. If it is in the smooth, if you consider the frictionless surface, then the frictional force is very less. Now to check the non-conservative system, we are considering the rough horizontal surface. Just consider one block at position, this position at position A. Now we are apply the force. If you apply the force, you know that this block, if the force which is overcome to the frictional force, then this block will be moving. So this block will be moved from distance A to position B. Okay. So this is position B. If you apply the force horizontally, this block will be moved from A to point B. Here, at the condition at point A, the block, at the block, there are the force, gravitational force, which is exerted in the downward direction. Here, this gravitational force will be exerted, or we can say that W, which is nothing but W is equal to mass into gravity. Simply we can say that instead of Fg, we can say that W is equal to mg. During the at the same time, the normal force will be exerted. If you not apply the force, the block will be at the rest at position A. Now, we are considering the example, we are applying the force. If you apply the force, motion of that block in that direction. This is the direction, so motion of the block from position A to position B, and we can keep back again. So from this forward direction again in the reverse direction, again block will be moving, same here also. This is W is equal to mg, and this gravitational force will be cancelled to the normal force. So in the forward direction, in the reverse direction, if you again apply the force in that direction, again there will be motion of that block. From this block will be changing their position from B to A. So here we can see that round journey from A to B and back brought to the again original position from B to A. So again this is the motion of that block. Motion of block. Okay, so here we can see that the force of friction in the first case or in the second case, if you apply the force, the block will be moving in the forward direction. At the same time we can see that the force of friction, or simply the frictional force, which is, you know that the frictional force will be exerted in the opposite direction. So when block will be moving in the forward direction from point A to point B, in that condition, this is the force of friction, which is force of friction, which is opposite direction. Same when this block which is moving from point B to point A, in that condition also, this is the force of friction. In both cases we can check that the force of friction, or simply frictional force, which is opposite to the motion. Here we can see that this frictional force which is exerted in the opposite direction. Now you know that this is your normal force, this is your gravitational force. Okay, you are considering the coefficient of friction between this block and this rough surface. If you considering the coefficient of that frictional force, which is nothing but mu. This is mu, which is nothing but the coefficient of the friction between that block and the rough surfaces. Now there is two cases. First case, which is the block which is moving from A to B, second from B to A. So from that two condition, the round trip will be completed. First we have to check, I am writing mu here, which is nothing but the coefficient of friction. So during this displacement S, this block will be displaced. So from A to B, the displacement will be S. Okay, so this total journey A to B, the displacement is S. So during this displacement S of that block, work done by that force is nothing but work done when this block will be, if you apply the force, block will be moving from A to B. So the total work done is nothing but, or simply work done, which is nothing but minus mu. Mu is nothing but your coefficient of friction between that block and rough surfaces. And here you get, before that we can take the force. The friction force is nothing but minus here the force of friction from A to B or B to A, which is nothing but mu times mg. The force of friction is nothing but mu times mg during from A to B or B to A. So we are considering the total work done. This is the force. This is the force. Displacement is nothing but the S. So the total work done is nothing but, you know that W is equal to applied force into that displacement, or simply yes. So W is equal to, the F is nothing but mu mg. It is mu mg into displacement S. Here we are defining that the work done W is equal to minus mu mg S, because there will be the negative sign. Why there will be the negative sign? Because the frictional force will be exerted in the opposite direction. Here we are considering the first case. Okay, this is normal. In the first case, when block will be moving from position A to position B, from position A to position B with the displacement S, or it cover moving from A to B with the distance S. So in that condition, when block move towards the right side, which is A to B, in that condition the force of friction which is directed towards the left. When this block moving into the right direction, in that condition the force of friction to the left side, or we can say that in that left. So the work done, so here the work done by that force of friction is nothing but W1. Here the work done by that frictional force, which is nothing but a W1, which is equal to, we can say that minus mu mg into S, which is minus mu mg into S. Now in the same manner, this block will be moving from right side, from A to B. At the same time, the frictional force which is moving in the opposite direction, or we can say in the left direction. Second condition, when block will be moving to the left side from B to A. In that condition, when this block will be moving to the left side, the frictional force or force of friction will be at the right side. Here the force of friction will be at the right side, and in the same condition the total work done is nothing but the W2, which is in that condition, which is again minus mu mg into S, which is minus mu mg into S. Okay, wait, yeah, I'm writing here. In first case, W1 is equal to minus mu mg into S. In the second case, W2, which is equal to again same minus mu mg into S. Okay. So if you considering in both the cases, you get W1 and W2, and there will be the negative sign just because of the frictional force or force of friction will be exerted in the opposite direction. If you consider the total journey or total work done in that round journey from A to B, B to A, you get W is equal to W1 plus W2, which is nothing but minus mu mg s minus mu mg gs, and which is nothing but you get the total burden will be minus 2 mu mgs. So here you get the total burden minus 2 mu mgs, which is not equal to 0. Here in this round journey or closed loop path from A to B, again back to the original position from B to A, in that condition you get the total burden will be W1 plus W2, and if you calculate or determine or adding these two terms, you get minus 2 times mu mgs, and we can see that which is the non-zero value. This is your non-zero value. So from our definition, again we can say that the work done by that force of friction in the round trip journey. Again I am stating that the work done by the force of friction between the block and rough surfaces in that round trip journey, will be minus 2 mgs, and which is not equal to 0, So this frictional force between the block and this rough surface will be, or we can say it is non-conservative force. This frictional force is non-conservative force, because from our definition of that non-conservative force, the work done by that force which is acting on that body in the round trip journey or in the closed loop gate, the work done will be non-zero, which is not equal to 0. And here in the frictional force, in that example, we can see this total work done will be non-zero. It means that our frictional force is non-conservative force.